I'd like to discuss what I believe might put my magic ghost number cubes to some use. If you can read this, this is the magic ghost number cube similarity to geometric Clifford algebra elements, namely the scalar zero vector point, which in my cubes are the central ghost numbers. The central ghost number in this case is 21. The number one vector, or the one vector, is a line. Those are the primary numbers. And those are 1, the pair, 1 and 4, 3 and 6, 2 and 5. They relate to each other in triples because it requires 2 to create using the commutative property requires a pair, and there's 3 pairs. These are the triples that starts off the whole cube. You can put them randomly if you want to, but they still relate in pairs because they use the commutative property to produce the outside, which are real vectors. This central green triples that starts them all off, primary numbers, the blue numbers, are pseudo-vectors, and so are all the others, like the area bivector, these orange lines that crisscross the 3 triplanes that make up the inner cube. So orange lines, they're the secondary numbers at the corners that, in this case, add up from the primary numbers to the corners. And those are the area vectors, or the bivectors. And the inner numbers they don't pass, I believe it's called the trapezoidal test for a unit vector, if they're not equal on both sides, or that they're not each other's inverse or something. 14 on both sides. So on their outer, for the area, are real vectors in that case, in that definition. And for these blue vectors, these lines, 5 on both sides, 7 on both sides on the outer, 9 on both sides, but on the inner cube, they're separate. They're different numbers that make up the pair. So I'd call those pseudo-vectors, and their outer pairs are alike, so they're real vectors. And the same with the inner ghost numbers in purple, the trivectors, pseudo-vectors, inner ghost numbers, they're pseudo-vectors because they don't equal each other, but their sum, in this case for an addition cube, does equal each other. 63 on this side, 63 on that. So that's a real vector, William vector. So you have the point, which is the central ghost number, 21. You have the lines, the one-dimensional lines, which are the dual pair of primary numbers in the inner cube. And you have the area vectors, which are the crosswise areas at the corners, the orange numbers at the corners of the inner cube, and the orange numbers on the outer cube too. And then you have the trivectors, which are the inner ghost numbers. And all this inner cube is all pseudo-vectors, and their outer products, or their outer sums, are real vectors. And the end of this is the outer numbers are all the same. They create the volume vector, which equals 1 in a unit. I believe if I'm saying all this right. And so these are, if I can get this right, these are the point, which is the central ghost number, the lines, which are the triple pair of primary numbers, so it's circled in green, the planes, the area vectors, the bivectors are the orange, swept out by the orange lines crisscrossing the inner and the outer. The inner planes, triple planes, that's the pseudo-vectors. Pseudo-volume is the purple inner ghost numbers, and the reason they're pseudo is like all the other inner cube numbers, they're not equal on both sides, but they're outer cube numbers, which turns out to be the outer ghost numbers. For the inner ghost numbers, their outer ghost numbers are the real vectors, their inner ghost numbers are the pseudo-vectors, and then that's how they relate to each other. But how the inner ghost number and outer ghost numbers relate to each other is that 21 is a triple 21